Hi, and welcome to Lesson 6A here in our Electrons unit. So here we're going to talk about quantum numbers. And of course, the letter after the number tells you that this video is very much an honors-only lesson. Here we see the box diagram for carbon, and what I've done is identified two of the electrons by their quantum numbers. Let's go in and take a look at this and see how this works. Quantum numbers are just a numerical electron description. It's a way of taking what we've talked about up to this point in our discussions of electron configurations and representing that information numerically. Every electron in an atom will be located in its principal energy level, in a sublevel, and in an orbital in that sublevel. Additionally, that electron will also have a spin. So there are four characteristics that describe any electron in an atom. The first quantum number is going to represent the principal energy level, and it's given a shorthand code of N. It directly equates to the principal energy level where the electron is located. So for instance, for this circled electron, that electron's first quantum number is going to be 2 because it's in the second principal energy level. If we were looking at one in the first principal energy level, it would be 1. If it was in the sixth principal energy level, it would be 6. The second quantum number is going to refer to the electron's sublevel. The code for this starts at 0. So if it's in an S sublevel, it's 0. If it's P, it's 1. If it's D, it's 2. And if it's F, it's 3. So for our example electron here, its second quantum number is going to be 0 because it's in the S sublevel. If it was in the P sublevel, we'd make this number 1. The sublevel quantum number is given the shorthand of L as a code. The third principal energy level is going to refer to that electron's orbital. We give it the code M sub L. Orbital numbering is always symmetrical around the number 0. So the S sublevel has 1 orbital. That orbital's number is 0. P has 3. So we start with -1, we have 0 in the middle, and then we end with +1. D has 5, so these range from -2 up to +2. And F has 7, so these range from -3 up to +3. For our particular example electron, its third quantum number is going to be 0 because it's in the S orbital, and the S orbital is 0. Depending on where that electron occurred, we might have to change our orbital quantum number to fit it. And our last quantum number is going to refer to the spin. This is given the code M sub S. It's the fourth number that gets listed. If the electron has an upspin, we give it a quantum number of +1/2. And if it's a downspin, we give it a quantum number of -1/2. For our example electron, which has an upspin, its fourth quantum number is +1/2. If it were pointing down, we'd give it -1/2. These are quantum numbers. Let's try some examples. This is actually not in your packet. I've got 3 different electrons that are circled here in Neon's box notation. Determine the quantum numbers of those 3 electrons. If you want to, pause the video and try it on your own, and then when you're ready, let's go through it together. So we're going to do them from the left to the right. The quantum numbers for the first electron that's circled are 1, 0, 0, +1/2. It's 1 because it's in the first principal energy level. It's then a 0 because it's in the S sublevel. The orbital in the S sublevel is the 0 orbital. And since it's got an upspin, it's +1/2. The quantum numbers for the second electron that's circled are 2, 1, -1, -1/2. 2 because it's in the second principal energy level. 1 because it's in the P sublevel. -1 because it's in the -1 orbital. And -1/2 because it's got a downspin. The quantum numbers for our last electron are 2, 1, +1, +1/2. I hope that it makes sense to you why. If it doesn't, take a moment and write down any questions that you have before we wrap up. Thanks so much for watching our discussion of quantum numbers. Take a moment here at the end and make sure that you can do the following things. Make sure that you can describe any electron of any atom as its 4 quantum numbers. Also make sure that you can identify valid and invalid quantum numbers. Why, for instance, would the second quantum number never be 12? These are the kinds of things that you'll be expected to do. If you can do these things, you're doing great. If you can't, that's okay too. Take a moment and write down any questions that you have. You can always leave those questions in the comments below the video, or you can always get in touch with me through the information in the info field. Thanks again for watching. I really appreciate it. Have a great day.